Good morning. Welcome to Breakfast in Biology. This is day 50.
50?
Which is interesting because it took us 50 days. This is the last kind of new information, kind of new us talking about something new. The plan is tomorrow. Tomorrow's Thursday. Good figure. And then the next day is Friday. Good figure. We're going to have a little competition. I think Thursday will be a Module A of the Keystone competition. Friday will be a Module B. We've spent all year preparing you guys for a Keystone test that you're not going to take.
Woohoo! Maybe.
Yeah, we're not. I mean, look at our faces. Do we look upset about that? Not really. But we are interested, some of you worked really hard. So let's do a little two last competitions. We'll see who the Module A winner is. We'll see who the Module B winner is. We're not sure what that's going to look like quite yet. I mean, probably you can Kahoot quizzes, something like that, right? So join us tomorrow and Friday for that, the last two times that you get to be with us as our students in biology. So we really hope that you're here. And we're glad that you're here today. And so, who is here today? Darius Trice is here.
Eli is here.
Paul is here.
Zuli, Lexi, Annie, Dom, Gladys, Maya, Emily, the Lurker.
The Lurker.
This is Clayball.
Home base. All right, so we're going to wrap up this evolution thing with a couple ideas. All right, so we have change over time. We've talked about natural selection, the mechanism that Darwin kind of came up with for how this evolution thing might happen. We've talked about speciation yesterday, microevolution. How do species actually change? And so today, the final thing is just kind of giving you some, I think, how Mr. Smith's going to talk a little bit about how we look at it and organize it a little bit. And then I don't know that we've ever given you the why. We've talked about the mechanism. We've talked about how it happens and all that. So Ms. Smith's going to talk about how we organize it, and then I'll give you kind of the why, and then we're done. So let's get it. Let's hit it. Mrs. Smith, I think you're starting here.
I am. So there's a couple of different ways you can organize things. And what's a little bit frustrating is they almost look the same. So I'm going to kind of talk to you about two different, basically, trees. You have what's called a phylogenetic tree, and then we have a cladogram. So a phylogenetic tree looks like this. It can look a bunch of different ways. Like there's ones that show branches and all sorts of things. The big thing about a phylogenetic tree is that it's showing how species are related, and it's also the length of the lines is supposed to designate time. So the shorter lines mean that it's a shorter time period between them. So that's what that one looks at. The other type is known as a cladogram. And a cladogram, which Mr. Suter is going to click and show you, typically shows features that are common to each group, but the lines don't have to be different lengths. So it doesn't necessarily mean that the same amount of time passed in between like a frog and a mammal and a turtle. You know what I mean? Like it doesn't necessarily go in time order. What it's showing are features that are common to each group. So it's a little bit different. So like phylogenetic trees show like common ancestry and look at time. Cladograms show common features. And so, because science is constantly changing and sometimes we move places of like where things are, where we think that, reptiles and everything are in the same family as this, and then we switch something and somebody goes somewhere else. So we use both. Okay. And so we're going to take a look at a cladogram and kind of doing one together. So here's an example, and Mr. Suter's going to flip over my end so that I can, I know it got a little bit smaller, but I want to kind of move it. So what I want you to do is I want you to look at all these examples on the bottom. Okay. So crushing mouth parts, curly antennae, double set of wings, segmented body, 6 legs, just legs, and then wings. So if we're going to start to move these around, and I know the letters are a little bit hard to see up here, but where would we put some of those things? So does anybody have an idea of what and where we would put it. So I'm going to put it a little bit bigger so you can look at it. So pick a letter and tell me where I should put one of these things. Anybody got one that they think?
In the chat, right?
Yeah, in the chat. No, I want you to run here,
Drop us a letter and a name.
computer, and move it.
Mrs. Smith's a little feisty today.
I am. I'm just happy to finally have a new shirt. I mean, look at this. Haven't seen this one in a while.
Oh. All right, we have F and wings.
All right, so F and wings. So if you look, all of the ones up the cladogram all have that feature. So I didn't say that. I wanted to see what you did first, but that's essentially what you have to do, because everyone that follows the line has to still have those things. Anything before it can't have those things. So the best place to put wings is right here, because everything above has wings. So now that we said that, is there any place anybody else thinks that they can put?
Okay, so Shay says A has a segmented body.
Okay, and I've got two different letters for double set of wings.
Right, so Annie said H has double set of wings. Eli says G has a double set.
Okay.
And so it's anything above. So is it H or G?
So what do you think, Mr. Shooter? Does segmented body go at A?
So I'm thinking double set of wings goes with what? We had H or G. And then somebody did say that H could also be curly antenna.
Ah.
So that does make a little more sense right there. So yeah, Annie, you were right on, I think. It just you needed to go down one because the dragonfly has a double set of wings too.
Right. So all of them have wings. Then when you hit this point, both have double set of wings, and then we've got the curly antenna. Crushing mouth parts. That's kind of hard. I didn't really tell you that. And then we have legs at B. Spider, 1, 2, 3, 4, 5, 6, 7, 8. So 6 legs should go
above the spider.
Okay. Anybody know crushing mouth parts? I'm gonna make it a little smaller.
So between C and F, you have D and E. So does that mean they each have something that nothing else would have? Help the students out a little bit with that.
Yes. So do you think it is the grasshopper or the ant? Or does it not go there? Do they all have crushing mouth parts?
Eli says D is crushing mouth parts.
So nobody else has crushing mouth parts? Just that, and they all have segmented bodies? I'm just asking. You see how sometimes things can start to get, you got to think about it and see where they can play. And I purposely left one off. We want to add in one for something else. Okay. So that's kind of how a cladogram would work. I don't want to take any more time because I want you to continue, Mr. Suter.
Well, do you want to put those last two where they go?
Sure. You want to put it here?
I need you to clean up that police station.
All right. There we go. All right. So if we go back to our thing. So that, I mean, Mrs. Smith was talking about phylogenetic trees, cladograms. It's all on how we organize stuff. And it is interesting that you can start, if you organize organisms based on their parts, you start to see, again, these relationships that we think that we have between organisms. And we see how we build, or not how we build, but how life kind of built. Anyway, Moving on, the other thing that I wanted to talk about is this idea of an ecological niche. We've used the word several times. I wanted to make sure that you understand it. I hate slides with text on it. I think you all can read. I shouldn't read to you. Mrs. Smith knows this is a pet peeve of mine, so it's funny that I would put it in. But ecological niche describes how a species relates to the ecosystem, includes what it eats, its resources it exploits, its physical capabilities, and so on. And here's what's interesting. No two organisms have the same niche. You can't occupy exactly the same niche as another organism. So when that happens, when there's competition, and that is competition, why do we compete? Because our niches start to overlap. And if niches overlap, then we got to compete a little bit. So when there is competition, there's really three options according to this chart. Number one, you can occupy the niche better than your competitor. Do it better. Push them out of the way. Number two, you can bring yourself out of direct competition by moving to a different place or being active at a different time. So say you and I hunt, or two organisms hunt at the same place. If one hunts during the day and one hunts during the night, maybe they're not in competition as much anymore. Or you become extinct. And so this is interesting. What does this look like? So here's just kind of an idea. You can look at a tree, and in that tree, we could have three different birds living, and one of the birds would live up near the top. The other bird might live in the middle of the tree, and the third bird might live in the lower branches. Bird is the word.
I can't believe you put Angry Birds in here, but okay. I didn't notice that before.
It's better than the Amoeba Sisters. So you get the idea a little bit. Let's dive just a little deeper into that. I have my slides backwards. I wanted this one. So all species that live in the same habitat, no matter how many aspects of the niches they have in common, will always have differences. And so this is, again, looking at that idea of birds eating different things, having different beaks, being adapted to different parts of that niche. So if we go back two, down at the bottom, it talks about a fundamental niche and a realized niche. And I thought an easier way to demonstrate that would be with this. So here's a barnacle. And if you look at it, it makes total sense. Because we talk about fundamental, realized, you get, what's he talking about? Makes total sense. We're not going to use their scientific names. We'll just call them blue and brown. The blue, let's start with the brown. The brown barnacle can occupy from all the way up here to all the way down here. That's its fundamental niche, where it could live. All right. It's able to survive outside of the water when the high tide goes out and you have a low tide. So it can survive for a period of time not being submerged. That's its fundamental niche. The blue barnacle's fundamental niche only goes this high. And so it cannot survive outside of without being submerged as long as the brown. Here's where things get interesting. The realized niche. The blue barnacle, though, can outcompete the brown. So notice what happens. It's outcompeted the brown for the lower region, up as high as it can go. So its fundamental niche and realized niche are the same. The brown, since it's been outcompeted, it has moved to an area where it doesn't have that competition. Since it can last longer without being submerged, it can go higher on the side of the cliff, and therefore its realized niche is very small, even though its fundamental niche is really big. So when we talk about niches are the part of the environment an organism uses. And if a niche changes or a competition is added, they have to adapt to that. So if you think about it, think about all this stuff we've been talking about, this whole evolution thing. We're talking about natural selection, survival of the fittest, whatever. What it really comes down to is as environments change, organisms have to adapt to that change. As new environments open up, say there's land that was underwater and something happened geologically or whatever, and now that land's above water, that's a new area. So organisms can come in and populate that area, to adapt to it. So the why of evolution, I think, is these kind of ever-changing landscapes, niches, and organisms competing to take advantage of them. Now, a great example of that, say you have a whole bunch of organisms that populate large areas all over the earth, and there's a catastrophe, there's a major change. That organism has to adapt to that major change. If it doesn't, what happens? So in the chat, if you have an organism that's living in an area and there's a major change in that area and the organism cannot adapt to that change to the new niches, what happens to the organism? Seeing if anybody's still with us. Major change, niches all change, the organism can't adapt. What happens to it?
And I worry a little bit, and this is my AP-ness coming out, that makes it, wow, I can't believe I said that. Anyway, is that like the AP brain of mine goes that when you talk about, you know what I mean, if they can't adapt, it's not that there's like, that they're all of a sudden going to, but that they don't have already the ability to do that. Or if they don't, you know what I mean? If there's not, like, it's not like, oh, we're there. All of a sudden the planet's covered in water, so we're going to develop gills. It doesn't work that way.
Right.
Oh.
So that goes back to, so if we think about Darwin's theory of natural selection, one of those things is that there's variation among species, and that as environments change, some of those variations are selected for, right? That make you more popular. If you have a longer neck and the trees are getting higher, you are more successful. You didn't grow a longer neck because the trees got higher. You had one, and now you're more successful because things changed.
Right. But if all the high trees died and there was only shrubs and you had to bend your head down, that would blood rushing to your brain, and you maybe wouldn't survive, and long necks wouldn't be preferable.
And then the short neck laws or nuts would be whatever. So people said in the thing, it dies, they go extinct. Yeah, and I think, and Mrs. Smith had another slide here. Right. If the population cannot adapt to changing environments, and the dinosaurs are a great example, right? You know, the story goes, whatever, there's a major catastrophe, many things changed, they could not adapt, they went extinct. But now, here's what's really special about life. Because when they went extinct, when there was major changes, and the environment changed, and the dinosaurs went extinct, all of a sudden, new niches opened. And there's an explosion of life right then, right? There's all these new organisms moving into new niches, taking advantages of areas they couldn't take advantage of before. And so now we see a whole new thing happening. But here's the thing. You know, like, I'm glad to see that you wrote extinction, because right now you're living in a time, right, Mrs. Smith? Would you call it a time of mass extinction right now?
Oh, boy.
So if you look through the history of the world, there's been several moments. 6? Am I right about that? We'd have to look it up. We're not experts on that. I think there's been 6 mass extinctions throughout history.
Trying to count. Five. Okay. 5 or 6, depending on.
Yeah. So if you look at this, if you go back 440 million years ago, right? They're giving you 6, and they're showing you 440 million years ago, 365 million years ago, 252 million years ago, 201 million years ago, 66 million years ago, and now 11,700 years ago to present is another time of mass extinction. According to this one chart, you know, people maybe whatever. there's so much to say here, but really this isn't the point, right? So maybe we shouldn't get into it. But I do want you to think about that, like as you listen to the news and as you watch things and you think about what's important in the world and what is not important in the world, the fact that people argue that maybe human activities aren't having as much of an effect on the world as what other people say they are. If you need a good barometer of when something's not right and there's mass changes happening, when you see mass extinctions, that's probably a good barometer. Like when we see the amount of species dying that we have dying, that should be a moment where you pause and you go, I wonder why that's happening. What's going on? And if you link that cause to human activity, then you might ask yourself, is that good? And we're not getting whatever. We're just saying. Anything to add to that, Mrs. Smith? Am I way off base or whatever?
No, it's just, we're going into another class.
Right. So, science, environmental issues. If you like that kind of stuff, maybe an environmental science class or whatever. But anyway, if you like, if you really dig into evolution stuff, think about AP Bio. Anatomy. If you like kind of the anatomy stuff, think about anatomy. So there's all kinds of great science classes, and we can talk about them now because this is like the last class. This is the last thing we're going to say to you as your bio teachers, other than, hey, let's compete a little bit and see who's been paying attention all year.
It's so weird to think that it's the end of the year.
Right. So if you could pick your books up and put them back in the cupboard, start cleaning up the tables a little bit. So weird.
Maybe that's why there's not as many people. Maybe some students because today is one of the days to clean out lockers during this time period, right?
I would say there's not as many people because some people are just done.
I was trying to give
I'm not giving any benefit of the doubt here. Come on.
Listen, all I know is that the cool kids are here. So.
Right. Grade book. There's no explanation points in my grade book anymore. It's all zeros. That's my grades. That's what I'm turning in. Unless you do stuff. I will continue checking for the rest of the week in the morning to see if anything was turned in. I will continue checking next week.
I'm going to try to get through all. I feel like I've missed some emails, so I'm trying to go back through 5 pages of emails and double check things. So
if you keep turning stuff in, I'll keep putting it in the grade book. If you do nothing between now and whatever, that's it. All right. Awesome. Anything else, Mrs. Smith?
No.
All right. Hopefully there'll be some people here to compete tomorrow. As always, wash your hands. Take care of yourself. We love you. We'll see you
tomorrow still. Yeah, we'll still see you tomorrow.
Yeah.
That May snow killed the strawberries. That's all I gotta say. I'm disappointed. It's gonna be a bad strawberry season.
You are cool, Emily. Very cool.